गुड मॉर्निंग बच्चों। आज हम राउल्ट्स लॉ पे कुछ न्यूमेरिकल प्रॉब्लम्स सॉल्व करेंगे। लास्ट लेक्चर में हमने वेपर प्रेशर और राउल्ट्स लॉ के बारे में कुछ डिस्कस किया था। आज थोड़ा सा रिकैप कर देते हैं। राउल्ट्स लॉ बेसिकली क्या कहता है, अगर हमारे पास एक सॉल्यूशन है सपोज ऑफ मिक्सचर ऑफ टू वोलेटाइल लिक्विड्स से A plus B, okay, in a closed vessel, then whatever the vapor pressure will be exerted by this solution, that is determined by the Raoult's law. So as per Raoult's law, the partial vapor pressure of A is directly proportional to its mole fraction in liquid phase, that is XA. Similarly, partial pressure of B is proportional to its mole fraction in liquid, that is XB. And we can say that partial pressure of PA equal to PA naught into XA, where PA naught is the vapor pressure of pure A and partial pressure of B is equal to PB naught into XB, where PB naught is the vapor pressure of pure B. So as per Dalton's law, we can say that total pressure exerted over the solution will be sum of partial pressure of A plus partial pressure of B. That is nothing but PA naught XA plus PV naught XB. So this equation will be used in our numericals, which we are going to solve. Okay. So what we can say, total pressure exerted by the solution, total vapor pressure, is nothing but PA naught XA plus PB naught XB. Now we will take first example. This says if 9.2 gram of ethanol is mixed with 6.4 gram of methanol, okay, and also it is given that vapor pressure of pure ethanol is equal to 8 kilopascal and vapor pressure of pure methanol is given as 16 kilopascal, and what is required is what we have to find out, a total vapor pressure of solution, and 2 composition of vapor phase, composition of vapor phase. Okay, this we have to find out. So we will apply the same formula, that is P total is equal to P ethanol, P naught ethanol into X of ethanol plus P naught of methanol into X of methanol. Now P naught and PM naught are given to us. What we have found to find out is the XC and XM, that is the mole fraction of ethanol and mole fraction of methanol in the solution. So how we will do? First we will find the number of moles of ethanol, say n number of moles of ethanol equal to mass V1 divided by molar mass of ethanol which is C2H5OH. So it will be 12 into 2 plus 6 plus oxygen 16. So it will be 46. So divided by 46, it will come 0.2. Similarly, number of moles of methanol will be mass given, that is 6.4 gram, divided by molar mass of ethanol. What is molar mass of ethanol? CH3OH, methanol. That is 12 plus 4 plus oxygen 16. So it will be 32. So divided by 32, and this will be 0.2. So number of moles we have found out for ethanol and methanol. Okay, now what we will do, we will find the mole fraction of ethanol, that is Xe. That will be number of moles of ethanol divided by number of moles of ethanol plus number of moles of methanol, that is total number of moles. Number of moles of ethanol was 0.2 divided by 0.2 plus 0.2, that will be half. Similarly, methanol mole fraction will be 1 minus Xe, that is 1 minus half, and it will be equal to half. Okay, so it is a equimolar solution, we can say, because both mole fractions are equal. Now what will be the total pressure? We apply this formula, that is PE naught into Xe. What was PE naught? It was 8 kilopascal. So 8 into half. And what was the methanol vapor pressure? It was 16 kilopascal. So this into half. So it will be 4 plus 8, that is 12 kilopascal. Okay, so we can say that the solution is exerting the vapor pressure, which is nothing but average of the two, that is 8 and 16, because it is an equimolar solution. Okay. Now what we have to find out is the composition of vapor phase. We know that vapor phase has also ethanol and methanol. So mole fraction of ethanol in vapor phase will be nothing but partial pressure of ethanol upon total pressure. And what is partial pressure of ethanol? It is nothing but this, that is PE naught into Xe divided by P total. So this will be nothing but, this is 4 kilopascal. Okay, just we have found out na, PE naught into Xe, that is 4 kilopascal, divided by total pressure was 12. Just we have found out it was 12 kilopascal. So this will be 1 by 3. Okay, and what will be Y methanol? It will be 1 minus 1 by 3, that will be 2 by 3. Okay, now what you see, that methanol Y mole fraction is double that of ethanol. Even though it is a equimolar mixture of ethanol and methanol, but the mole fraction of methanol is double that of ethanol in the vapor phase. What does it show? Because methanol is more volatile. As we saw, the vapor pressure of methanol was double that of ethanol. Vapor pressure of methanol was 16 kilopascal and vapor pressure of ethanol is 8 kilopascal. Okay, that is why this mole fraction of methanol is double that of ethanol in the vapor phase, because methanol is more volatile. Now we will take one more example. The second example says that they have given the vapor pressure of pure A and B, that is PA naught is given as 450 mm of Hg and pure B vapor pressure is given as 700 mm of Hg. So we have been given a solution of liquids A and B whose vapor pressures are these, and this is at 350 Kelvin. Because vapor pressure depends on temperature, so they have specified that at 350 Kelvin these are the vapor pressures. What we have to find out is the composition of liquid phase as well as vapor phase. And what more we have been given is the total pressure is given as 600 mm. P total is also given as 600 mm of Hg. Okay. So what we have been given is the total pressure as well as the vapor pressures of pure A and pure B. And what we have to find out is the composition of liquid phase and vapor phase. So we will employ the same formula, that is P total equal to PA naught XA plus PB naught XB. Okay. So this will become 600 is equal to PA naught is given as 450 into XA plus PB naught is given as 700 into XB. XB, in place of XB I will write 1 minus XA. Okay, so this will become 700 plus 450 minus 700 into XA. Okay, and this if we bring on the left side, so it will be 250 XA will be equal to 700 minus 600. So this will be 100. So XA will be 100 divided by 250, that is 0.4. And once we know XA, then XB will be 1 minus XA, that is 1 minus 0.4, that is 0.6. So we have found out the composition of liquid phase, where mole fraction of A is 0.4 and mole fraction of B is 0.6. Now we also have to find out the composition of vapor phase. So how to find the composition of vapor phase? That is YA and YB. So what will be YA? If I write YA, that will be partial vapor pressure of A divided by total pressure, and this is nothing but PA naught XA divided by total pressure. What is PA naught? 450. What is XA? We have found out 0.4 divided by total pressure is 600. So it will be how much? 450 into 4 divided by 6000. Okay, so this will be cancelled out. 15 55 40 10. So it will come 0.3. YA is 0.3, and what will be YB? YB will be 1 minus YA, that is 1 minus 0.3, so it will be 0.7. So we have also found out the composition of vapor phase, where mole fraction of A is 0.3 and mole fraction of B is 0.7. Okay. Now you can see the mole fraction of B is higher because B is more volatile. B has a higher vapor pressure. Now we will take one more example. So this will cover all the type of examples that have been asked in the previous exams of IIT JEE. Now we take one more example. It is given that liquids A and B form ideal solution for all compositions at 225 degrees Celsius. Two such solutions, means these are the two liquids A and B. Okay, and they have given two solutions with one with 0.25 and other with 0.50. That is the mole fractions of A. They have given the mole fraction of A, this and this. Then those solutions will have total pressure PT of 0.3 and 0.4 bar respectively. And what we have to find out is the vapor pressure of pure A is required. What we have to find is PA naught. Okay, vapor pressure of pure A, that we have to find out. What is given? Two solutions, one with mole fraction of A as 0.25, other with mole fraction of A as 0.5, and the total pressures of these solutions are these. And what we have to find out is the vapor pressure of pure A. So what we will do, we will consider this solution 1 and solution 2. Solution 1 has XA equal to 0.25 and P total is 0.3 bar. Solution number 2 has XA equal to 0.50 and what is P total? 0.4 bar. Okay, so these are given, and what we have to find out is the vapor pressure of pure A. So what we will do, we will apply the same equation, that is for solution 1, this P total equal to PA naught XA plus PB naught XB. Okay, so this will give what? P total is 0.3 equal to PA naught. PA naught is, we have to find out. Okay, and into XA. XA is how much? 0.25 plus PB naught into XB. What will be XB? 1 minus XA, that is 1 minus 0.25, that is 0.75. Okay, because XB will be 1 minus XA and XA is 0.25, so we will write this. 1 minus XA will be 0.75, that is XB. So this is equation number 1, and similarly for solution 2 we will make another equation. Okay, so we have made with solution 1 and now we will make for solution number 2. So for solution 2, what will be the equation? P total. P total is given as 0.4 equal to PA naught XA. PA naught we have to find out into XA for solution number 2 is 0.5 plus PB naught into what will be XB, that is 1 minus XA, so it will be 0.5. So this is equation number 2. So we have to solve the equation number 1 and equation number 2 to find out the PA naught and PB naught. So there are two equations and two unknowns that we can easily find out. Now I take one more example. Which says that the vapor pressure of, it is given that the vapor pressure of pure benzene and toluene are, pure benzene and toluene are 160 and 100 mmHg respectively. Okay, and what we are saying, that the mole fraction of benzene that we have to find out in the vapor phase. If it is a, they have given that if this mixture is a equimolar mixture, if this solution is a equimolar mixture of benzene and toluene, okay, this is given that it is a equimolar mixture of benzene and toluene. What we have to find out is the mole fraction. Find mole fraction of benzene, mole fraction of benzene in vapor phase. So that we have to find out. Okay, so how we will go? What is given first of all is, say, pure benzene. I write PB note. Its vapor pressure is given as 160 mm of Hg. Similarly, vapor pressure of pure toluene, that is PT note, is given at 80 mm of Hg. Now you see, benzene being a smaller, this less molecular molecule, it has a higher vapor pressure, and toluene being higher in the homologous series, it is having less vapor pressure. So it is equimolar. They have said that it is a equimolar. So that means what is X of benzene is equal to X of toluene is equal to 0.5. That is why it is equimolar, because total has to be equal to 1. So these are given. Now what I will write the formula. This I will put in the formula. This is our formula. So P total. Okay. What will be P total? PA naught. I will write this equation as PB benzene PB naught into XB plus PT naught, that is for toluene, into XT, that is for toluene. So after putting this, into this equation, I will get P total is equal to, what is PB naught? 160 into 0.5 plus what is PT naught? 80 into 0.5. So this will be how much? 80 plus 40, that is equal to 120 mm of Hg. So what you see, because this is an equimolar mixture, so the vapor pressure of the solution is average of the two vapor pressures of pure components. So 160 plus 180 by 2 will give 120. Okay. Now what we have to find out is the mole fraction of benzene in vapor phase. How we will find out that? So formula for this is Y of benzene is equal to partial pressure of benzene in vapor phase, that is the partial pressure divided by total pressure. So what is partial pressure of benzene? This is this much, PB naught into XB, that is 80, divided by total pressure. What is the total pressure? That is 120. we have just found out total pressure as 120. So this will be 2 by 3. So the mole fraction of benzene is around 0.67. Okay. So that is the answer. Now I take one more question, that is the last question. This will cover all the possible questions that can be asked in any of the competitive exams or in the board exam. So last question, which is given as total vapor pressure of an ideal solution, total vapor pressure of an ideal solution of benzene and toluene is given by, that is experimentally that they have determined this formula, that the total pressure of the solution is given by P total is equal to 100 plus 60 into XB, where XB is the mole fraction of benzene in the solution. And what we have to find out? Find vapor pressure of pure benzene and pure toluene. Okay, so the vapor pressure of this solution is given by this, they have determined experimentally, and where XB is the mole fraction of benzene, and what we have to find out is the vapor pressure of pure benzene and pure toluene. So how we will do? We will write the same equation, that is total pressure is equal to, say I write PB for PB naught for benzene, that is the pure benzene vapor pressure, multiplied by X of benzene plus pure toluene vapor pressure multiplied by X of toluene. Okay, this is the same formula for vapor pressure of a solution. Now we eliminate X toluene from this formula, and then we write this as PB naught into XB, okay, plus PT naught into XT. I will write as 1 minus X benzene, because toluene and benzene, this is a mixture. So this will become as PT naught, this I can write as PT naught, plus this will become XB, I take common, so it will be PB naught minus PT naught into XB. Okay, now you see, now if we compare this equation with the given equation, what we will find, if we compare these two, okay, we will find that what is PT naught? PT naught is 100. So by comparing, we find PT naught is equal to 100 mm of Hg. And what is this? PB naught minus PT naught into XB. So this is also 60 into XB. So by comparison, we know that PB naught minus PT naught will be equal to 60. PB naught minus PT naught will be equal to 60. So by this we know what? We have to find out PB naught. So what is PB naught? That will be equal to 60 plus PT naught. 60 plus PT naught, and PT naught we have found out 100. So it will be 60 plus 100, that is 160 mm of Hg. So we have found out the vapor pressure of pure benzene and pure toluene. Okay. So this is the last question which we have to discuss here. With this we cover all the different types of numerical problems asked based on the Raoult's law that have been asked in the exams, various competitive exams so far. Okay, now we will conclude this session. In the next section we will take colligative properties for a solution where a non-volatile solute is dissolved in a liquid. So that we will take in the next session. Okay, thank you.